All right. Hi, guys. So this is going to be the first section video for chapter 14, where we're going to talk about single case experimental research designs. Um, think of single case. Oh, you know what? Let me turn this battery thing off there. There we go. So it won't quit going dark on you guys. So the single case or single subject is what it's sometimes called experimental research design. That's referring to when there's only one or possibly a couple, but usually it's just one person, one subject, one participant that you are getting information from. Um, and the example your book gave at the beginning of your chapter is a study that was done on how to help disruptive behavior in the classroom. And so they looked at a student or, maybe there's two students, but usually there's usually just one or two that were being consistently disruptive in the classroom. And they instituted the program or the method of tootling. So instead of tattling, tootling is, basically tooting someone's horn, right? Is the idea of that, is um, bragging on or, um, calling someone out for reporting good behavior, positive examples of behavior instead of tattling for bad behavior or, negative behavior. And they, compared the instances of disruptive behavior in the classroom before, for that student, before and, during or after, telling what tootling was. And then they stopped doing the tootling and they went back and did it again. And here's the chart, the figure 14.1 from your book that shows that when they were doing the tootling method, that the disruptive behavior you see is on the y-axis over here, the vertical axis. So you can see that the instances of disruptive behavior were much lower on the tootling times versus the baseline before the tootling and then withdrawal period, which is when they took the tootling program away. And so you can see very easily from this graph that it is likely that this tootling has some sort of effect. And so that's kind of a basic example of what this single case experimental design is trying to do. So from that, you can see that it is very similar to it is experimental in the sense that we're trying to demonstrate cause and effect relationships, and there is a treatment or a manipulation of some kind, but it's also has elements of a case study because it is a single person. There's lots of description and observations, um, and that's where we're getting that data from. Is the detailed description and observations, and then it's also a little bit like a quasi experimental time series design that we talked about, because there's a series of observations happening over time. And so there's a lot to unpack here. So this icebreaker obviously has to be done in person, and we cannot do that in person. So instead, I want you to think about examples of times that you have either been interviewed, or maybe you've had a chance to interview someone else, or you have witnessed an interview. Think about your experiences with interviews, and think about the kinds of information and the amount of information you were able to get. And again, you can pause this and think that through or write some stuff down if you would like. But the chapter objectives for this chapter, there are 5 on this slide and 6 on this slide. And so there's 11 total. And we are going to jump right into the introduction, and that is going to address learning objectives 1 and 2. And so the first one is the goal of single case research, and we're going to explain how they are related to, or how single case research is related to experimental designs, descriptive case study designs, which we already kind of talked about a second ago, and quasi-experimental time series designs, which again we talked about a second ago. And then the second objective we're going to talk about is identifying basic elements of single case experimental research designs that make them specifically experimental, which is the manipulation and the control. And that includes baseline observations, multiple and stable observations, and then replication of treatment effects, which we will talk about all that in just a moment. So to get you guys in the mindset here, for single case experimental design, again, it can be called single subject or single case. The goal here is that we want to we want to be able to get results from a single participant or a subject. So why would we do that? Why wouldn't we use multiple participants or multiple subjects? Well, this is great. The advantage here is for those situations when only a single individual is available, maybe, or a single individual is being treated, observed, and measured. Examples of this would be in a clinical setting. If you wanted to see if a specific treatment worked, like there's data to support that this specific treatment has a cause and effect relationship, that it works, that it causes changes in their symptoms or their behavior, and so you want to see if that works, and so you would apply that to your patient, your single patient, and you would follow this design that we're going to discuss and see if the treatment actually causes a change in their behavior or their symptoms. Similarly, school psychologists or school counselors can use a single subject or single case experimental design when trying to implement some sort of treatment or program that is going to improve behavior or academic performance or whatever the case may be. And so this is those situations where this comes in handy. The goal, obviously, is to establish the existence of cause and effect relationships. We just said that's what makes it experimental, but also what makes it experimental is that there is a manipulation and there is control. Those two components are included. They are a must in order for this to be considered experimental, obviously. And what are we controlling? We're controlling those extraneous variables because we don't want any alternative explanations for the results that we get. Again, that's what makes this experimental. So how do we do that with a single participant? Well, you have to have these 3 elements here at the bottom of this slide. You have to have a baseline, which means there's a clear measure of whatever the behavior or whatever your dependent variable is. There's a clear measure of that before any sort of treatment or manipulation. And then you would have repeated observations over time, before, during, after, wherever, however you need to do it, depending on what your variables are, to check for any outside influence. So if you are getting results that you didn't expect, or you're noticing possibly the effects of something else that is not the variable you're interested in, you can alter, you can change, you can fix things, whatever. And so there are repeated observations to check for these things, to check for those outside factors that could be influencing any extraneous variables, and things like that. And then the third component here is replication. And what that means is if you notice that there are changes in behavior or your changes in your dependent variable, you're noticing there's an effect. Great. But are we sure that it was because of the treatment? How do we verify that? Well, because it could just be chance, it could be something else, And so to in order to support it more, you would continue what you're doing and see if you can get the effect to show itself again, a second demonstration of that effect. Because while one demonstration of the effect may be coincidental or maybe due to something else, if you have a second demonstration of the effect, then it is more likely that there truly is an effect there, that there truly is a cause and effect relationship happening. So how do we, what does this look like? What do the results look like for a single case experimental design? You don't really get data, like a group of scores to do statistical analysis on, right? Because you don't have more than one participant. You only have the one participant. And so tests for significance and things like that are not used. They're literally evaluated just from using a simple graph. It is a visual, it's visual evidence. That's the word I'm looking for. Evidence that you are evaluating, that you are looking at when you're talking about a single case experimental design. So this right here is showing you the most basic example, the most basic form, where you have each dot is a day of observation. So you can see they were observed 5 days. The student was observed 5 days before treatment. And then the dotted line here, the vertical dotted line, is showing you where the treatment occurred between day 5 and 6. And then day 6 through 10, each dot is showing you what the disruptive behavior you see over here on the y-axis. It's showing you disruptive behavior is what these dots are. You can see the disruptive behavior after, during the treatment, after the treatment started. And so you can see visually that it's likely that this treatment is decreasing the disruptive behavior. You can see this very easily visually. But the problem with just this simplest form, simplest design, is that the graph is not enough to show that the treatment was the only cause, because there could have been outside factors that caused this dramatic dip in disruptive behavior. Maybe they were tired, maybe they got sick, maybe they made a new friend and they were happy and they didn't act out in class anymore. I mean, you just never know, right? And so it could also be the result of chance. That's the second concern here. It literally could just be for chance. And while in a group experimental design, there are statistical significance tests that we can perform on the data. We can't do that with a single case study. And so how do we combat that? We're going to talk more about this as the chapter goes on, but this is why that third component, that replication component here, is so important, because the graph must be able to show without a doubt that the cause and effect relationship is there, for one, and that the treatment is the sole explanation for the results, right? The treatment is the sole explanation for the effect. And you only have this one source, this one participant, one source of data or information. And so that's why replication is so important. So that's why a graph like this is more convincing, because you can visually see, yes, it went down. If you just look at the first two columns there, the baseline and the tootling, this looks like our other graph we looked at. And that looks like, yeah, there's something going on. But then to see it happen again, where they took it away, the tootling away, this withdrawal, and the destructive behavior went back up. And then when they reintroduced tootling again, it went down again. That obviously is stronger evidence to support that cause and effect. So that just kind of gives you guys a quick introduction to single case experimental designs. And so we're going to do this learning check really quickly. There's just 2 questions. How are single case designs similar to other experimental designs? So hopefully you guys can look through these answers and see the data are evaluated with traditional tests for significance. Well, obviously, I just told you there's no test for significance here, so that's not it. They do involve a series of observations over time, but again, that doesn't that has nothing to do with an experiment, and we're talking about how it's similar to experimental designs. And so the answer is that they are capable of determining cause and effect relationships, right? That is the key element of an experimental design, and that is why they are similar to other experimental designs. Again, they do involve several observations of participant before treatment and after treatment. That is true, but again, that is not a defining factor of an experimental design. Number 2, why do single case designs use a series of observations of the same individual under the same conditions? Okay, so same individual, same conditions. Why would we do that? Well, obviously, we're not computing means and variances. I already said we're not doing that. You only have one person. And so it has to be one of the other 2 answers here. And so we do want to demonstrate this third answer. We do want to demonstrate that observations demonstrate that the treatment is causing the behavior. We do want to demonstrate that, but using a series of observations of the same individual under the same conditions that's not the sole reason that we do that. The same individual under the same conditions is to ensure that it's not being influenced by outside variables. Because if we were to change things all the time, then those outside variables would be really hard to see. Or if we were looking at different people and all that, it would be very hard to see. But by looking at the same person under the same conditions in a series of observations, these outside variables, the influence of them is a lot easier to observe. So that is it for 14.1. If you guys have any questions, as always, you can email me.